Okay, so let's talk about something you probably never think about, but rely on every single second of every day. The power grid. It's this massive interconnected web that brings electricity to your home so you can charge your phone, play video games, and most importantly, power your microwave to reheat that questionable leftover pizza from last night. But what happens when something goes wrong? Like a lightning strike or a tree falling on a power line. You get a power surge, a massive spike of electricity that could fry everything. To prevent a citywide blackout, we need a superhero. That hero is the sf6 circuit breaker, an incredibly fast and powerful switch that protects our entire electrical infrastructure from catastrophic failure. In the simplest terms, it's a high-voltage switch. When everything is running smoothly, the switch is closed, and electricity flows through it like water through a pipe. But the moment it detects a fault, it needs to open that switch and stop the flow. The problem is, when you try to separate two contacts carrying massive amounts of electricity, the electricity doesn't want to stop. This is where the sf6 part comes in, a colorless, odorless gas that's really good at quenching electrical arcs. Before a single bolt is turned, the first step is all about preparation. This is where the pros separate themselves from the amateurs. First, you need a perfectly level and stable concrete foundation. This is Safety 101. Assume every wire is live until you've personally locked it out, tagged it, and tested it to be dead. This lockout-tagout procedure is non-negotiable. Next comes the main assembly, which feels a lot like putting together a giant high-tech sculpture. The main support structure is lifted into place by a crane and carefully bolted to the foundation. Then, the interrupter chambers are hoisted and mounted onto the support structure. Every bolt has a specific torque value, which is followed to the letter using a calibrated torque wrench to ensure a perfect, secure fit. With the mechanical assembly complete, it's time to introduce our superstar, the sf6 gas. A gas handling cart pulls a deep vacuum on the breaker's tanks, removing all the air and, more importantly, any moisture. The gas is filled to a specific pressure level designated by the manufacturer. The gas density monitor is now calibrated. It's basically the breaker's fuel gauge for sf6 gas, and it'll alert operators if a leak ever develops. Now we move on to the electrical connections. This is where the danger level ramps up, so safety is absolutely paramount. The high-voltage lines are connected using specialized clamps and massive hardware. The low-voltage control wiring connects the breaker to the substation's control room. The final step is a comprehensive battery of tests: timing tests, contact resistance tests, and high-voltage tests to verify everything is perfect. We've seen how these massive, powerful guardians are assembled, from the concrete pad to the final electrical tests. It's a process that combines brute force from cranes with the delicate precision of a watchmaker. So what's the one practical tip to get the job done right the first time? Read the manual, then read it again. The manufacturer's instruction manual is the single most valuable tool you have. Trust it, follow it, and don't cut corners.